again. I think it's 8 p.m. in Ontario. It's 6 p.m. here in Calgary. It's nice to be here again with the NIPCA family. And so today we'll be talking about blockchain technology and its emerging opportunities. So the last time I was here, I talked about cloud technologies. So I'm hoping that at least maybe some people got something from that last session, but feel free to reach out to ask about stuff. But for today's session, I'll be taking you guys through a set of slides, which I prepared. And after the presentation, then we'll now go into a Q&A session, which will be coordinated by the team. So without much ado, I'm going to share my screen and then we will take it from there. So share, all right, come on. Okay, so just a second here. I think full screen, probably getting old. Okay, cool. So can you guys see my screen?
Yes, very well.
So this starting is a little bit about me. Osita has already said almost everything, but I've been working in tech for over 20 years. And in Canada, I came to Canada in 2018, early 2018, and I've worked as a consultant and engineer with places like Deloitte, WestJet, and RBC. I was senior cloud architect at RBC before moving to start my own thing. So currently I work at my own startup, Clock Software, and we build identity solutions using AI, blockchain, biometrics. And our slogan says, identity solutions that the world can trust. So yeah, that's a bit about me, and we can jump into the main subject. So what is the blockchain? That's the question you want to ask. I know I'm talking to a group of techies, but I'm sure there's some of us in the group here who are a bit new to this particular area. So I'm going to take you from scratch as if you're just hearing about blockchain for the first time. So basically, a blockchain is essentially a distributed ledger or a collection of records. And in this collection of records, each record it's linked to the other. Now, the records themselves are stored in blocks. You can think of them like ice cube blocks. And each block contains a bunch of records. The next block now knows the records are in a particular block. There's a record in another block. There's a record in another block. And each of the blocks are linked together by cryptographic keys. So each block knows the previous block before it, and vice versa, like that. So that's where the term blockchain came from. So you can see in the slide, you can see the way these blocks here, these cuboids are linked together. So this particular block here was the one that came before this one. So this one knows that one, like that. Then another way you can think of blockchain is like a database that exists in multiple locations at the same time. So that's one special thing about blockchain is that you can think of it like a database, in fact. But this same database exists in hundreds or thousands of places. And all of them are replicas of each other. So if I make a change in my own copy and I scatter something here, I go and change and I assign, for example, a blockchain for a bank that is storing maybe customers' balances. The balance on my account must be the same with the one that all the other computers and all wherever this database is. They must all be the same. They must all rhyme. They must all agree. So any change to one without all the others or majority of the others accepting that will cause kasala, like they say in Nigeria. So that way, the blockchain is immutable. It is decentralized, so nobody controls the whole thing. So if my own record or my own system that has the blockchain, mine collapses, the whole thing still lives on other machines. So you are completely safe. So that's one thing that makes blockchain extremely powerful. So like I said, think of it like a database, a distributed database in multiple locations, with each location have a copy of a transaction or records, thereby making it decentralized and tamper-proof. Now let's talk about the history of this blockchain. I'm sure everybody has heard of Bitcoin. I don't think there's anybody here who hasn't heard of Bitcoin on the group. But what we call Bitcoin today actually kickstarted the blockchain movement or blew the blockchain movement up. But the whole concept, the whole technology behind it was worked out in 1991 by a bunch of scholars. I think one of the guys called Scott Stonetta. And they figured out how to create immutable records or immutable tamper-proof timestamps. But it wasn't until 2008 when Satoshi Nakamoto, this is a guy who we say in programming, this is like, the guy is like a god in programming. Like He's the only person to have written perfect code, and he's the one who actually was the brains behind blockchain technology. He defined the white paper that eventually became Bitcoin, that eventually set aside the entire blockchain ecosystem. Now, this guy, people say nobody knows who this person is. People say it's actually a group of people. Some say no, it's actually the CIA. Some say it is one guy. Some people say it's Elon Musk. So some say it's a pseudonym. So there's been, till today, we don't know who Satoshi Nakamoto is, but that's the person who conceptualized the cryptocurrency movement and wrote the white paper in 2009, gave birth to Bitcoin. So basically, that's the blockchain history regarding that. Now, so how does blockchain work? And this is a very important concept, because if you say we have a record or a ledger that exists in several places, so how does each of the ledgers, how does each of them stay in sync or with all the others? That's what we want to talk about here. So we talk about the authentication. So every transaction that is written on the ledger or on the database or on you can think of it like a notebook. If anyone who doesn't know database, I think of it like a record. Any of the records that are written there must, first of all, the writer must be authenticated. So, and the authentication is done using what they call cryptography. So cryptography is an advanced field in mathematics where we encrypt and decrypt stuff using algorithms. So on the blockchain, there's a whole lot of cryptographies, what you care about private keys, public keys. So in order for me to write to a ledger, I must authenticate that I am the true person. So by providing either, I have my own private key and I have my own public key also. So the two must match. I won't go deep into cryptography, but I just want you to understand that there's authentication behind this and in the workings of blockchain. Then the other bit is authorization. So if is anybody anywhere allowed to just write anything? So authorization basically is like, what are you allowed to do on the blockchain? So there's authorization on the blockchain, and each on the network of the blockchain, we have what we call nodes. Every computer that stores the records or the ledger is called a node. So like on the Bitcoin blockchain, you have about 10,000 nodes spread across. So for you to actually, for you to write a transaction, you actually have to be authorized to do so on the blockchain. And there's a way it's set up in there. Now, there's a very important concept that you must understand. One of the things you may have heard, if you want to discuss, if you talk with blockchain enthusiasts, you might hear them say consensus protocol. So, okay, this particular blockchain was a consensus protocol. So now, I mentioned earlier that the blockchain is basically a ton of computers all over the place. And if I write a transaction, I try to change something, the majority or a large number of the computers on the network must agree. So they look at their record and say, okay, my own record has Neji's balance as 1,000. Osita's records look and say, my own record has Neji's balance at 1,000. You have maybe Professor Jegsy, his own record says 1,000. All of us have records of the same thing. So if somebody changes, if there's a change somewhere, the change must agree with the majority of the machines on the network. So that's what we call the consensus protocol. So the machines must come to a consensus. They must agree. And the way the consensus protocol works, it works through two main approaches. One of them is called proof of work, while the other one is called proof of state or proof of stake. So I will explain proof of work right now and how that approaches into Bitcoin mining. Because some of you have heard about mining. Oh, this guy is in Bitcoin mining. So basically, proof of work requires that all the computers on the network, so each of them, in order to be able to write a transaction or a block on the blockchain, each of the computers must solve a very difficult mathematical problem. So when I solve the problem, I am given the right or the privilege to write records on a block and push it to everybody within the network. So that's what they call mining. Now, those mathematical problems or those equations are so complex that it can take your computer 1 million years to solve it, and it requires a lot of power. So what happens is that the guys who designed this, they designed this in order to ensure that not anybody should be able to write nonsense on the chain, because they want to keep the records as spam-free as possible. So that's where this proof of work thing came up. So you have you have lots of miners, people who in Canada here, Bitcoin mining and crypto mining is a very big business in Canada. So some people even go to Manitoba Hydro. I think there's a mine. There's some folks who went and put a dam somewhere and they're using the power, because to actually run these computations takes a lot of electrical power. So proof of work allows the miner to actually prove that, oh, okay, I have solved this problem, and this is my I have the rights thereby to write some records or to write into a block on the chain that all the other computers will accept. And in my reward for that is that I will get, for each transaction that is written, I get some kind of fees, or I get some Bitcoin in return. So that's sort of the Bitcoin mining area. It's a specialized area. We can talk about it later, but I just want you to understand what proof of work means. Now, the other consensus protocol, again, is called proof of stake. So some new blockchain networks have adopted this proof of stake because, first of all, the Bitcoin mining, the proof of work algorithm is a bit strenuous. It's difficult, and it consumes a lot of electricity, and sincerely speaking, it's not very good for the environment. So they say, so the proof of stake algorithm means that for each of the people who have computers on the network, each of the nodes that support the network, or each of the people who host databases, you can think of them like hosting companies, each of them must show proof that they have a certain amount of that cryptocurrency. For example, on the Ethereum network or on the Bitcoin network, if we're doing proof of stake, so I must have a certain amount of Bitcoin in order to be allowed to write on the network. So that's what proof of stake means. So it means that you must show that you have enough skin in the game to be allowed to that, and it's a very expensive process. So this is the two major consensus protocols you need to know: proof of work, proof of stake. So let me proceed to the next one. So now let's talk about Bitcoin. So basically, I mentioned before that Bitcoin came into being in 2008 and 2009. There was a white paper by Satoshi Nakamoto, and Bitcoin is now the king of the crypto world. In fact, Bitcoin has blown up so much that a lot of companies like Tesla are even beginning to accept Bitcoin. And Bitcoin has actually allowed us to sort of like question and rethink the entire meaning of money. So the concept, how Bitcoin came about, is that the so-called Satoshi Nakamoto did not like what was happening in the 2008 financial crisis, when a lot of banks were collapsing and government had to bail them out and all that. So he envisaged a kind of a digital form of money where I can send money to you guys, or you can send to me, or we can all send money to each other with all via the internet without actually having to deal with middlemen. Because right now, you want to transfer money to Nigeria now, you have to send it to, first of all, you either use WalletMe or you use TransferWise. The thing must hit the CBN first. CBN must approve. Then it has to go to a bank, and there are fees all over the place there. So the original idea behind Bitcoin was to eliminate all of that, all those obstacles, or all those middlemen in the way, and that's where Satoshi came up with Bitcoin. So currently, Bitcoin has a network of around 10,000 nodes, and they're using the proof of work system. That's what they do currently. Now, the other crypto that we talk about is Ethereum. So in fact, this is even the most powerful application of blockchain technology was given birth to by Ethereum. And it was built by a Canadian software engineer called Vitalik Buterin. And Vitalik, he lives in Ontario also. He's a very cool guy. So basically, he was one of the contributors to the Bitcoin source code. And he figured out that the blockchain or the Bitcoin network shouldn't just be only for sending money or be for cryptocurrency, but people should be able to build decentralized applications. So an application that actually can live on the network and execute activities based on what they call smart contracts. So that's how Ethereum was born. So Ethereum basically came out in 2015, and Ethereum has grown tremendously. In fact, is currently the most active blockchain environment right now, because so many applications are built on Ethereum. So Ethereum basically lets you build what they call decentralized apps using a process called smart contracts. I'm going to explain what smart contracts are in a bit, but just think of Ethereum as a programming platform. It's not just a blockchain where you send money and all that. It has its own coin called Ether, but at the same time, it allows you to even build your own cryptocurrency on top of the Ethereum network. In fact, I'm actually writing one. I'm writing the whole cryptocurrency right now. I will show you guys a bit of my code and whatever, but it is, Ethereum basically uses a language called Solidity, so which I'll go into. But to understand and this is in fact where the opportunity lies. In fact, guys, I will tell you the truth. It lies with Ethereum and the Ethereum clones, more or less. So let's talk about smart contracts. I don't know if you've heard about smart contracts, but you may have heard the term smart contract. When I was at RBC, I used to hear smart contracts a lot. I was a cloud engineer, but I would hear the folks say, oh, some guys say, oh yeah, the smart contract that deals with an agreement between the client and maybe the bank, and then the bank has to do a few things and all that. So I was curious, what are these smart contracts? So in a nutshell, a smart contract is a self-executing contract. So you know what a contract is. If I sign an agreement with you, I'm paying you for a house to rent an apartment. Let me just use an analogy. When I was in school in Nigeria, I schooled in Futo, Owerri. The first time I left the hostel to go to get a house outside, there's this particular guy who rented his father's one of the bedroom in his father's house. He rented it to about 16 of us, and none of us knew. So all of us paid money. Only on the day we were meant to move in, I went in there. We saw this guy. We saw the other guy. Say, "I'm a guy. I don't get a house, so they come in." So we're like, "What? Like, what the hell?" So this guy actually rented this apartment to all of us, and I lost my money. I didn't enter police matter, but you know now how police is. So, but the smart contracts, the way they work is that this kind of scenario cannot happen if smart contracts were in place, because the smart contract will behave like this. Once I have the apartment is listed for rent, it's listed, the smart contract pulls the apartment in, understands a piece of code that understands the listing. It will list the apartment. Now, when the money has been paid, the smart contract will verify that the money is in the bank account or the money has been received before it releases the key to the apartment, and only one key can be released. So in that case, a smart contract in place would sort of prevent the same apartment being leased out to 16 of us like it happened. So basically, that's in a nutshell, that's how you can think of a smart contract. So it's a piece of code or it's a construct of self-executing code where nobody's supervising it. It's just developed, it is written and designed in a language on the Ethereum network called Solidity. So yeah, I will show you a bit of what smart contracts look like, but they are powerful and they form the basis of the new internet, if I'm gonna put it that way. So yeah, just remember, if you try to remember the smart contracts, you forget about what it means, please remember my story, how it happened, so you can always remember what smart contracts do. So this is an example of a smart contract. It's actually a coin I was writing. So basically you use the Solidity language, and it's a very interesting language. If you know Java, JavaScript, C#, or any programming language at all, you can easily learn Solidity. It looks like a bit like a Java, it looks like a bit like JavaScript, but it's a mix of a couple of them. So I will encourage, if you want to learn Solidity, I have a bunch of materials that I will send out, a bunch of links I will send out at the end of the class, the session, so you can check it out. Now, what areas do we use smart contracts on the Ethereum network? In trade and finance, this is used to trade. Today, you have escrow services that are built on the Ethereum platform, where if I'm sending money to you, I can send Ether. In fact, guys, you might be surprised to find out that a lot of the money transfer services, I don't want to mention them, they're actually using crypto at the back. So I don't know who works for which one here, so I will not mention the names. So basically, it's the idea behind smart contracts is what powers all that in trade and finance. In real estate and mortgages, this is a very good use case I just mentioned. And based on my own experience, I think this is one of the strongest areas for smart contracts. Insurance is another area too. Healthcare, because on the blockchain, the records are literally almost immutable. So if I have my health records, nobody can tamper with them, or only I myself can access them. So healthcare is a good area too for blockchain and smart contracts. Electronic voting and elections. This is one area too. And at the end of the lecture, I will show you a demo of another app which I'm building that allows you to vote on Big Brother Nigeria using AI and voice. So it still has blockchain at the back. So we use blockchain to power the voting I'll just run the video for you guys to see. Then you have supply chain management, and then the two giants, like I like to call them, DeFi and NFTs. So DeFi and NFTs, these are currently the two biggest areas right now in crypto. Initially, it used to be ICOs and the rest, but DeFi means an NFC. So we'll go into DeFi in a bit. So what is DeFi? So DeFi is a short form for decentralized finance. Decentralized finance, basically, I'll say it's an umbrella term for a bunch of financial applications. In fact, the entire banking system is being rewritten as we speak. You know, the traditional bank since I think the 1500s, when banking was introduced in Italy, I think in Venice, that's where they had the first banks. You had to go into a bank, you put your money in, and then after a period of time, your money will start to yield interest. The bank takes that money and now donates it to they take that money and they loan it to another person. They get interest. Sometimes the banks get super greedy and then they will go and overloan, like what happened in the 2008 financial crisis, and they crash, and then people's monies are gone. So the traditional financial model has its own downsides. So that's why DeFi was actually created. So DeFi reimagines and completely disrupts the entire current financial model by providing a decentralized system where services such as banking, loans, insurance are completely powered by smart contracts. These same smart contracts I mentioned. So most DeFi apps are built on Ethereum, and the few popular ones are Compound, DeFi, and Aave. So let me explain something. How the DeFi thing works is that they are now decentralized loan agencies right now that live on the blockchain. They're not powered by any human being. They're just a bunch of smart contracts. So what happens is that if you have certain crypto, I have Bitcoin, I have Ether, which is Ethereum in this case, some Ether, I can stake my Ethereum into what they call a liquidity pool. I put that Ethereum in, and the Ethereum starts generating interest for me. So now other people, what they do is that someone needs a loan, you need a $100,000 loan. You can, if you have some Ethereum, you can come and put your Ethereum as collateral and now collect the $100,000 loan. They will send you the money as a what they call a stable coin, either USDT or that. You get that money. Now you already have put collateral in there. When you're paying back, you are paying back a certain amount with interest. So the people who stake their Ethereum, the people who stake their money or their crypto in there now are now earning interest on that crypto because the smart contract is using it to loan other people. Other people are using it to trade. You know, Bitcoin trading is a very big business right now. It's a $1 trillion business right now. So some people use other people's crypto to trade. So in the process now, the traders and the tradees, if you want to call them that way, or the people who stake their ink or the investors, and are earning, some of them are earning higher rewards or higher interest than even the traditional banking system. And in this approach, because everything is powered by smart contracts, we don't have a case where somebody will say, or so you don't have fraud. It's transparent. You can see everything happening on the entire network. So nobody is trying to bamboozle anybody or playing tricks at the back. So there's even decentralized insurance. So, and a whole lot of stuff. So the current DeFi platforms that are popular, there's one called Compound. There's Compound, there's DFIP. DFIP, I think, is a decentralized finance for, I think they do insurance, they do a whole lot of stuff. And then they even Aave, they do loans. So DeFi currently in 2020, early 2020, DeFi was just a $2 billion market. As of yesterday, DeFi is an $83 billion market. In 1 year, there's been almost 80 times growth in this sector. And it has been, in fact, this is what's driving the current bullish run on the crypto space. This is what's bringing all the attention of the big players, DeFi. So this is one area you might want to look at. It has immense opportunity, but please be careful, just like every other space and every other activity, especially in crypto, you have to be very careful. And like we said, this is not financial advice. This is just showcasing opportunities that may exist out there for you to explore. Now, the other thing we need to talk about is NFTs. So, in fact, this is the one that is mind-blowing, and it is, this is what I think will completely revolutionize the entire blockchain ecosystem. So what is an NFT? NFT stands for non-fungible tokens. So in order to understand what that means, you need to understand what fungibility is. So when you say something is fungible, it means that one aspect of one thing, for example, this iPhone, I have two iPhones here or another phone. This iPhone and this iPhone are the same. So it meaning that I can exchange the two as long as nothing is inside. They both are the same thing. So they are called fungible. So you have a currency. For example, I have let's assume I have Canadian dollars here. I have two. This is even a better example. I have two $20 notes. Now this $20 is always going to be equivalent to this $20. So there's no way, if you like, I take this one trade away, the two are always going to have the same value. So that's why it's called fungible. So there's fungibility. So a non-fungible item is an item that cannot be equated to anything else. So the original, the one and one is the one and only. So anything else, even a clone of it, no matter how well done, that clone cannot have the same value as the original one. So, and one of the areas that you find non-fungible items are art pieces. So I give you an example, the Mona Lisa painting by Leonardo, which one is it by Michelangelo again? So those originals go for hundreds of millions of dollars to buy the original one. You know, there are copies everywhere. The artists who have created the same copy of the Mona Lisa, but no matter the copy you create, it can never be the same as the original one. So the Mona Lisa painting is a non-fungible item in that case. Now, non-fungible tokens basically this same idea from art eventually diffused itself into the crypto space, into the blockchain space. And a lot of artists were creating artworks digitally. So you could see people creating, even recording a song, the original of a song, or even the original tweet. You know, so somehow people now figured out that, oh, these digital items are collectibles. These items they have value on their own. But because they can easily be copied and pasted, that's where the problem was. So with NFTs, blockchain brought out the opportunity where any item that has been minted as an NFT, the original stays, there's a reference to the original item. And even if it's copied 100 times, it can never be the same as the original. So that's what NFTs mean. So non-fungible tokens are like that. So digital art is an area where we saw, I think a couple of months ago, some guy sold a digital painting that he has been doing for 13 years for $69 million. That's what the recent NFT token, I think, yeah. So lots of people are making a lot of money from NFTs. So there are a lot of websites that where you can go and create your own NFT. So if you have an idea for maybe, you have an idea for a drawing, you have an idea for a code, you even have if you're a good speaker, if you're a musician, you can create NFT out of your own art pieces, out of your own work, out of your effort. And people will go on these platforms, what they call the bidding platforms, and bid for them. So NFTs are another big area. Then one other area too is in gaming. And why I say NFTs are going to be very big is that, I don't know if any of you guys who play games, you realize that sometimes you buy items on a game. You buy a ball, you buy a weapon, you buy a torch or a coin. And what happens? After that, whatever, some of the items, you never use them in the game. But if that game goes south or a new version is released, you've lost all the items you bought. You understand? So what happens to that? So NFTs are making their way into gaming, whereby people are thinking, why can't, if that gun I bought in this shooting game, why can't I sell it to somebody else within the same game or even in another game? So that's where NFTs are coming in. So people are beginning to see that electronic digital items, that used to be disposable, might actually have a lot of value. So as a developer, if I build an NFT, maybe for a game, and each time that NFT is sold, I'll get a cut. So it's like secondhand market. So if, for example, they sell my coin, anytime it goes to another game or another platform, they sell it again, they resell it. The developer will get a cut. But NFTs are very big. It's an area you need to look into pretty well. Now, we must talk about something that it took a while for me to understand this, but it's something that's important. Token versus coin. You hear that used interchangeably. Some people hear, oh, this is a token. What is a token? What is a coin? So in technical terms, a coin is built on its own blockchain. So when you hear coin, you're talking about the cryptos like Bitcoin, like Ethereum, Litecoin. These are built on their own blockchain. So a coin exists on its own regular blockchain. Now a token is built on top of an existing blockchain. So to build a coin, you've got to go write your own blockchain. You got to be a C++ or what's the other what do you call it? The other mad language again?
C sharp.
You got to know. Say?
C sharp.
No, C sharp. You can't do it with C sharp. It's C++ or C, or you got to do is it Rush?
Python.
No, you can't even do it with Python.
Not Python.
You can't do it with Python. What the hell? See, I'm forgetting things. Anyway, you've got to be it's called Rust. The language is called Rust. The language had that, so it's called Rust. So you got to know Rust. You got to be an operating system developer at that level, mad without the social life. That's where you've got to go to actually build your own blockchain, to build your own coin. So most of what developers do today is that they build tokens, even though we call it something coin, because a token is built on top of an existing blockchain. So a lot of tokens we build today are built on top of the Ethereum blockchain, because Ethereum allows us to program smart contracts. So there are other blockchains, technologies too, that allow you to do smart contracts, like Neo. Neo is the one that's very popular in China. You can build your own apps using C# or any of the other languages, Python, from there. Neo is popular too. And so just take note of that difference. A coin is minted, is straight up, you're writing your own blockchain just to build your own coin. But a token is basically built using an existing blockchain. That's the difference between the two. So now, this brings us to another area called cross-chain technology. I'm sure some of you who might be trading crypto, you may have heard of Cardano, you may have heard of Polkadot. These are some hot terms, and you're wondering, what is Cardano? What is all this Polkadot? So basically, these are projects currently that are trying to bridge the gap between multiple blockchains. Like I mentioned to you, to write your own coin, you got to be a mad person to write your own coin. You've got to be all crazy, So now, why do I? Because if I have your own blockchain, if I have Bitcoin, why must I go and change my Bitcoin first into Ethereum before I can trade Ethereum? Because I cannot trade with Bitcoin on an Ethereum blockchain. Please take note of that. For those who don't know, you got to convert your Bitcoin or sell your Bitcoin for Ethereum, and in the process, you will incur fees, or they call gas fees, and then you now have to trade. So these guys came up with what they call cross-chain platforms. So that's what Polkadot and Cardano are promising to do. So they say they are creating a network whereby you can sell Bitcoin on an Ethereum blockchain. You can sell Ethereum on a Bitcoin blockchain. You can sell Litecoin. You can sell different tokens on the same network, and it will work on all the other networks. So it's a very popular area in crypto space, and you can check it out. Cardano and Polkadot, they are pretty new projects that are in here. So now, let me see how much time I have. Okay, now let's talk about permissioned enterprise blockchain, and this is the area where I am more attuned with. So up until now, we've been dealing with what they call permissionless blockchain or public blockchain. Now, as IT professionals, a lot of times what you're going to work with in corporate organizations is likely to be the enterprise blockchain. I'll give you an example. Currently, we said if you post a transaction, if whatever transaction happens on the ledger, that's either on Bitcoin ledger or Ethereum ledger, is visible to everybody, right? It's visible. So anybody can go in there and see what was done in there. And the companies don't like this because they have trade secrets. So if I want to have say, for example, I have an agreement with an individual or another company, we don't want that information public. So most companies now, the need for having that sort of privacy, but at the same time, still enjoying the benefits of blockchain technology, which is the scalability, decentralized approach, led to the creation of what we call enterprise blockchain or permissioned blockchain. That's what it's called. So unlike Bitcoin and Ethereum, this ledger is not public, it is private. So banks use it, a lot of companies use it. And the platform that is used by these organizations fall under what they call the Hyperledger Consortium. So you may have heard of Hyperledger. It's in fact it is the king of enterprise blockchain right now. So basically, let's talk about Hyperledger. So Hyperledger is a consortium. It's a suite of projects run by the Linux Foundation, and it's supported by several large corporations like IBM, Cisco, Dell, and all the rest. There are like 50 major companies in the world that power the Hyperledger project. And so Hyperledger aims to adapt and provide blockchain tech for enterprise use cases. And there are two very popular Hyperledger projects. The first one is called Hyperledger Fabric, and the second one is called Hyperledger Indy, or Hyperledger Aries. That's what it's called. So Hyperledger is a new area, it's an emerging area, which I really encourage folks to learn, because a lot of the tech corporations, a lot of the big corporations in North America are moving to Hyperledger. They have realized that with all the cybersecurity threats, they need blockchain technology to survive the way the internet is. So Hyperledger Fabric, Hyperledger Indy are areas. I have done Hyperledger Fabric, and I'm actually also a Hyperledger Indy developer also. So I will tell you guys about each of them, and I will show you some projects that are done with Indy right here. So Fabric, let's talk about Fabric. So Fabric is like, you can think of Fabric like a Bitcoin or Ethereum blockchain, but it works using what we call channels. It works using what we call, it works using certain protocols that ensure that only if I'm talking to you, my organization has a Hyperledger Fabric instance. You can set it up in the cloud. It's set up on AWS or Azure. My instance, certain kind of data, I can talk to your instance, maybe another organization, and we can agree to share information. And we can agree to become what they call a pair. So other people can join the network too. So for example, RBC has a Fabric instance. You have ATB Financial, you have a bunch of them there. So they can communicate and transfer sensitive info across themselves, or they can come together and form and act like a small pseudo Bitcoin blockchain that way. But they are very sure and they're not allowing anybody else from the outside to write into them. So that's how Fabric works. Very powerful, some nice courses on it, and it's pretty interesting. But to learn Fabric, you've got to know JavaScript and you've got to know the language called Go. So those are the two areas you might want to look at. Now, Hyperledger Indy and Aries, in fact, this is blockchain for identity and access management. I mentioned earlier in the beginning that VisoClock, the company I started, basically what we do is we're into identity and access management. That's where we are. We use AI, blockchain, and all that. So we are big on Hyperledger Indy. Now, Indy, there's a new concept. Okay, let me just go back a little bit. The internet, the advent of the internet, currently the internet has a very flawed identity model, authentication model. We're using emails and passwords. Now, the fact is, on my Gmail, I use the same password that I use for my Yahoo. I use the same password that I'm using for my office work or office email. I'm likely using the same password for my banking and all that. So if somebody has access to just one, I mean, they're able to actually access all my stuff. And that's where the source of all the hackings and the BECs and all that, that's where it happens, because there's something called correlation across all of them. You know, so there's a source of weakness. So if one platform is hacked or hijacked, before you know, all my credentials are on the dark web. Look at what happened to the CRA. The CRA had to block almost 800,000 accounts. I say 800 or 800,000 accounts ahead from logging online because their information was found on the dark web. There was a hack with people's usernames and passwords all available there. It was in the news recently. So this is one of the challenges with the current model of the internet. Now, the Hyperledger Indy project is trying to rewrite that model using something called self-sovereign identity. Now, with self-sovereign identity, I control my credentials. My credentials are not stored on any central server. Rather, what's happening is that a public key that's referenced to me is stored on the blockchain. So if I need to authenticate or to log into your website, for example, now you would request for my credentials. I will choose what I want to send you. I'm not just sending you my whole date of birth, sending everything. No, I will choose what I want to send you. And then you can check on the blockchain to check whether it was actually valid or that's a fake credential or a genuine one. And so in essence, power is brought back to the user. So you, the user, control access to your identity. That's what it's called self-sovereign identity, SSI. So it's a new paradigm. In fact, they call it Web 3.0. That's what the internet is going to be built upon for the next decade or so. Now, a lot of the big companies like the Yahoos and Facebooks and whatever, Gmail, don't like this because if the user is able to control what you do with his identity or control access to his or her identity, that means that Facebook cannot tell whether you are the guy who likes plantain or you're the girl who likes to go shopping, like they currently do, because they will need your permission, they need your access to it. That's why SSI has not really taken off like that. But if it's coming, the new laws like GDPR, PIPEDA, and the rest that are saying, hey, everybody must, they don't support this new approach. So this is an area you want to look into and get into. So there's also something called zero knowledge proofs. I will show you guys a small application that we just built for storing COVID test details. It's something we're trying to push and all that, but it's completely built on Hyperledger, the Hyperledger India ecosystem. So basically, I want to jump in before I go into this closing remarks. Let me just showcase. Let me just showcase my the few applications that are using some of these technologies that I just talked about. So the first one I'm about to show you guys, it's just a slide, but it has screenshots of it. And this platform is called Testified. Please let me know if you can see my screen.
Yes, we can.
Yeah. So this is Testified. So basically what it does is that it uses this same Hyperledger Indy verifiable credentials model to actually ensure that only genuine vaccination or genuine COVID test results are being carried around. I don't know if you guys heard of the story. You probably heard of the story of this, the Nigerian family who came in with fake COVID tests. I was in Nigeria in January, and I must tell you, it's a wild west out there. People are buying fake COVID tests and stuff. It was very rampant. People traveling, and this created some problems there. So we built this application as an approach whereby every test that was being produced in the lab was stored in the blockchain, and you were utilizing self-sovereign identity. So your COVID test result is stored in something called a wallet that you control. So if you went into the airline and you went for maybe a COVID, you were about to get on the plane, the airline can confirm instantly whether that test was genuine or not, without having any middleman in between or having to call the lab or whatever. So this is a use case. It uses something called zero knowledge proofs. It's the same Hyperledger Indy and Aries approach that we're talking about. And that's what this platform actually does. So that is a use case for that. Then another use case too is another application that we built called Paytalk. I'm just going to share my screen and play a small video that shows you the demonstration of Paytalk. I mentioned that we're using it to try to see how we can power voting for game shows. Currently, we're talking to Big Brother Nigeria and a few of those Big Brother people on how to use it. It uses blockchain at the back and uses AI and biometrics to make it easy for you people to vote. So just a second here. Let me share my desktop and you will see. Okay, sorry. Please let me know when you can see my screen.
Yes, we can.
Okay, and this is Paytalk currently. We use it for booking flights and all that. So just please let me know if you can hear me, if you can hear this.
Welcome to Paytalk. I'll start by introducing this platform. So basically, Paytalk.
Can you guys hear? Sorry,
yes, yes, we can. Yeah.
Yes, we can hear. We can.
That allows you to carry out transactions just by speaking. So the idea is behind that rather than you taking a few steps, it's just as you think it, you can say it and it can work. So with Paytalk, you're able to make donations, you're able to buy shares, you're able to load airtime. And there's a feature we're introducing where you can actually vote on live game shows. So as an example, I'm going to demonstrate how you can vote on Big Brother Nigeria. This isn't up yet. It's just a sample demo, but to show you what the capabilities are within Paytalk. So Big Brother Nigeria is a very popular show within Nigeria. In fact, it's one of the highest rated shows on cable TV, and it's followed by a lot of Nigerians in diaspora. And the problem now is that a lot of them cannot vote, or they have difficulty voting because you have to either go to the website, which is, I think, is it Mnet or multi-choice, and you have to enter your details, make a payment. So it's quite kind of a process to it. And a bunch of people have actually stated that they were turned off by voting. I've heard up from few people said they couldn't vote because the time it takes to start typing the name, text, this text, type the person's name to a certain short code, all of that can be shortened and made easy using Paytalk. So without much ado, let me show you how it works. I will just tap on the microphone here and say who I want to vote for. So if this was the 2020 BBN edition, you had a bunch of contestants. So I sort of created fake or pseudo profiles for them. So check this out. Vote for Erica on Big Brother Niger. So I just stated who I wanted to vote for. And the platform is quite intelligent. It has natural language processing and AI that's able to pick. You can see Erica, this is Erica, tells me you're about to vote for Erica on Big Brother Niger, and the vote costs 100 Naira. Of course, this is set, hard set, but definitely it will be on the real thing. It will be pulling from what the current price is, and I can go ahead, yes, and pay with my card or pay from my account, and it works like that. Now I can try another one. Let's say I want to vote for Nengi. I would like to vote for Nengi on Big Brother Niger. So you can see I just spoke naturally. It doesn't have to be like my voice. Sorry, it doesn't have to be. Just a second, please. Yeah. So like I was saying, it doesn't have to be. I don't have to say it in a specific way. It understands the intent, and I can easily just throw it in there. So the other things that Paytalk can do is that I can send money to even churches. I can pay my tithe. I can make donations. I'll show you that, for example, here. I'll say, I would like to donate 20,000 Naira to the Red Cross. You know, I just stated what I would like to do, and Paytalk picks up my intent. And if the entity that I have mentioned is on the platform, like I said, Red Cross, you would see it pop up right here. You can see Red Cross of Nigeria. I can go in here. It picked up the amount, it picked up the currency, and it works pretty well. So yeah, this is Paytalk. Let me know what you think and how this can be used in game shows. I look forward to hearing back from you guys. Thank you.
Okay, so basically that was that's one of our apps that we are coming up with next month. It's called Paytalk. I'll let you guys know once it's out, but it uses natural language processing and machine learning, AI, biometrics, and blockchain technology at the back to make it very simple and very convenient for you to buy stuff, to vote, and do a whole bunch of things. So the reason I showed this is it's not out yet. We're still homing it, but it's that we foresee a future where there's a convergence of all these technologies is happening. So cloud, at the back of this is AWS, at the back of that is Azure, and there's Google Cloud. So a lot of the stuff you guys were learning is very relevant to real life applications there. So as part of my closing remarks, before we move into the Q&A session, I would say that we should pretty much please open your minds, like learn stuff. Just like Osita says, it's not only your own area, you know, learn as much as you can. And I'm always available to assist anybody with directions, to point you in the direction to whichever area in blockchain you want to go. If you want to go on the crypto side, you want to go on the identity access management side, you know, you want to go on the enterprise blockchain, whatever, we're available to also assist. So thank you very much, and we'll take questions now.
Fantastic. Wow. This is interesting, right? You know, when we talk about technology, the beauty of technology is about innovation. You know, and what you've done tonight is not just about talking about blockchain, but also, you know, trying to expand our thought process, you know, so that we can see how some of these things can come to life. You know, if you are learning AWS, Azure, you know, C#, Java, Python, there are areas through which, you know, in terms of how do we, you know, take all these skills and knowledge that we are learning, you know, into the, that is talking about now go-to-market strategy, because it's not all about learning. Somebody will say that invention, when you talk about invention, you need to, you don't just invent, but you need to think of how to commercialize the invention. So that is what Neji is doing. And we're very proud tonight having you on board. Trust me, you've been able to, you know, dissect a whole lot of concepts within a very short period of time. I was just looking at the time, less than 1 hour, and look at, you know, the information has been massive. Thank you so very much, Neji. We really appreciate you. Again, sometimes I'm just wondering how you're able to keep up, right? So many stuff you are coming up with. The last time we had a presentation with you, you showed us a couple of apps, and now you're talking about Paytalk, you're talking about Testify, you're talking about, I mean, the portfolio is really increasing, right? On daily basis, man. That is awesome. That is awesome. Fantastic. Thank you so very much, man. Yeah, so going straight into Q&A, let's see what we've got in the chat. If we don't have much in the chat, probably we just ask, you know, the audience to unmute themselves and possibly, you know, ask their questions. Let's see. Please, can I have the the recording this? Let me see. I'm thinking about no. Okay. 1 second. Let's see what we've got here. Great stuff. I love this. How can we invest? Okay. Someone is asking, how can we invest?
Okay, basically for that one, you'll need to get back to us. We'll talk later. That's backdoor conversation. We have to close doors. Okay, but yeah, we'll talk about that later.
Yeah, but actually we are quite open to that, right? It's not like okay, fantastic. Sure. Right? We are going to have more conversation. Then of course I'll bring it to the community for sure. Great stuff, amazing. Let's see. Do you see the financial sector using Hyperledger projects?
Currently, the financial sector is actually using Hyperledger actively. In fact, the banks are some of the major ones. For Hyperledger Indy, which is the identity aspect, we have the nodes. I mentioned that blockchain has some computers hosting the databases. So, but for Hyperledger Indy, we call them stewards. So one of the biggest hosts of stewards is ATB Financial in Calgary, has a steward. If you go on the Sovereign network, you see them there, they're there. So the banks are already ahead on this, sincerely. And the financial sector stands a lot to benefit from the tech.
Wow, amazing. All right. Then another one says, another question was, what is the use case for travel agencies? I think based on the app you showed, you talked about a few use cases, right? Okay. You talked about travel agencies. You talked about airline. You talked about elections. So for travel agencies, what is the use case? Is there like any use case that you can talk about?
To talk about that, I'll just share a video. Permit me to show you a 2-minute video.
Yeah, please go ahead.
How it's used for travel agencies. So let me share. I'm sharing my sound, and please let me know once you can hear. Sorry, let me get this. Right, closed. And okay. Hello, good afternoon once again. I would like to show you guys something on Paytalk. So this is Paytalk. It's a mobile app that you can use to do a bunch of things like make transfers, make donations and all that. So now we have added a new feature that allows you to buy flight tickets just by actually saying it. So as you might be aware, it is most of the time, if you go to an online service, like maybe a travel service, you can buy your ticket, you specify your start city, you specify your destination city, and do all that kind of stuff. But with Paytalk, you can use your voice and quickly run through search, and it shows you what airlines or what flights are available. So that's what I'm going to demonstrate. So I'll quickly just tap the microphone button and say, find me a flight from Lagos to Abuja. So I quickly asked for Paytalk to find me a flight to those destinations, and it will pull out a list of flights shortly that are available for me to utilize. You can see that here, available flights Lagos to Abuja. I have a bunch of them on a particular day. I didn't specify the dates, but you can also say the days and it will find you for that specific date. So you can see I have this flight here prepared for Lagos to Abuja. I can book this flight, either pay by card and pay by bank account, and instantly the flight will be booked. I will demonstrate this again in this case. So I can say, get me a flight from Lagos to Port Harcourt. So the unique thing about Paytalk is that you don't necessarily, it's not voice command, it is more or less AI and natural language understanding. So you speak to it and it understands your intent. It understands that you want to get a flight from Lagos to Port Harcourt on a certain day you specified. In this demo, we didn't specify the date, but That is provided for you also. You can say the date and it will pick the particular one. These are the closest flights we have on that day. And you can see the airlines in this case. Like this is an Air Peace flight, and I can board. If I board the flight or make the payment, I get an email and all that. So yeah, this is Paytalk. It can be integrated with your travel agencies and flight networks. Let me know what you think. Okay, I hope that answers the question for the user. So for a travel agency, you can actually utilize the platform too. In fact, what we're doing is we're currently integrating with a bunch of travel agencies to be able to provide ticketing services on that platform and make it easy, just like by speaking or even just asking, and it will do.
Yeah. Fantastic. I mean, this is awesome. Then, in fact, it's like you've got all use cases, right?
We even have buying stuff, like we're building something for ordering food. You know how you take the food, your stuff, and say, I want to eat. You already know what you want to eat. So when you go to see the dishes, why should I have to go and start looking for my menu when I can just say, I want to eat assume with maybe shawarma or whatever, and it will do the menu search for you and find you the restaurants around you that do that, that have that menu. So that's a use case that we're also putting. We have both things. We have even on the Nigerian Stock Exchange, we have we're talking with them for buying shares. You can just buy shares on that by saying where the share price you want or whoever you want. You know, so those are features that we're coming up with, and like I said, all powered by blockchain, AI, cloud technology.
Yeah, this is awesome. This is awesome. Great, Prof. Jexi, I know you are here. You've got also a bunch of questions, right? Go ahead, unmute yourself and ask your question.
Okay, thank you so much, Neji. This has been very enlightening and eye-opening. I would say the only thing I'm familiar with in all the things you said today is the word that are English, the one that are in English. Every other thing are new to me. You know, the don't let me even bite my tongue. But the one that really caught my fancy is when you mentioned about identity management and privacy and cybersecurity. You know, that's my line of interest. You know, of recent, there has been increase with ransomware attacks, especially on K-12 schools. You know, and because schools have limited budgets, so they are not able to invest in robust cybersecurity infrastructure and all of that. So I want to know what are the promises that crypto or blockchain technology holds in cybersecurity and in terms of for low budget institutions, you know, entities, you know, that are faced with cyber threats by actors. What are the promises that blockchain technology holds in this respect?
Hey, thanks, Prof. Jexi. To answer your question, I would say that it's an unfortunate scenario we find ourselves in these days where schools are being attacked for ransomware, and you know how devastating that can be. So blockchain, especially both the enterprise and the permissionless blockchain, let me use the term, has so much to offer. But the problem is that we don't have enough people who are experts in this or who are thinking in that line or thinking of building. We still have so many blockchain engineers, people who are doing Bitcoin and crypto, thinking that's the only space that's visible to them. That's the only arena they're seeing, or vertical that they're seeing. So as we get more people into the ecosystem, they will be able to see or be able to come up with ideas that can help or assist organizations that don't have huge budgets. So I give you an example. Now, how blockchain can be used to mitigate cybersecurity challenges is that I give you Hyperledger Indy, for example. If you developed a logging system where every teacher had to go through, authenticate through that. In fact, we're building a platform also called VeriSelf on Hyperledger Indy that is to authenticate and change and sort of like eliminate the need for passwords completely. So if you have that ecosystem or something like that in place, and we're making it affordable, we're not targeting just banks, we're not targeting one for anybody to be able to download and use it. You understand? So the there needs to be more innovation in the space. The technology itself is out there. It can solve that problem. If you want to store files, you can store your files on a Hyperledger Fabric network if you want to do that. And even if there was ransomware, nothing, your stuff is still secure and safe. So the decentralization, in fact, is the key. That's what solves this problem. Decentralize your stuff. Don't keep it in one place. Let it be everywhere. And that's what the philosophy behind blockchain is. So we need to get that to that point where we can start having schools. We need more people. We need more people to come into the space, and that's sort of one of the reasons why we're having this lecture, to encourage folks to come in and build more products like that.
Sorry, just as a follow-up, increasingly these days, privacy laws are everywhere. And countries are making things very more stringent with their privacy regulation. You mentioned GDPR and PIPEDA. Yeah. And the Canadian government is introducing another one called the CCPA that is in an advanced form of the PIPEDA. Yeah. Now, one of the main things that some of these privacy regulations are looking to is the storage of data. Okay, cross-border storage of data. Now, with this, from what I understood from your presentation, with blockchain, you can't really regionalize and say this is the location where the data is. Is that correct?
Well, yes and no. So that's why we say we have public blockchain and private blockchain. I explained to you that within the Hyperledger ecosystem, a lot of reasons why enterprises face this challenge. Government says you cannot store your data outside Canada. So it means that whatever nodes or whatever computers or setup you have has to be within a certain region. So it means that you can actually say on permission blockchain, you can say, I want my data to be only stored on nodes that are in Canada. That's what solves that problem. But on the public blockchain, like on Bitcoin or on the general Ethereum network, you are not able to say, oh, I want my stuff only stored here. So that's the difference. And that's where a lot of the promise for the future of privacy laws, regulation, and all that lies with enterprise blockchain or permissionless blockchain. Sorry, permissioned blockchain. Yeah, and that's what we are pushing. So like the apps I showcased to you are using permission blockchain. They're not on the Bitcoin, they're not on Ethereum. We set up our own Hyperledger instance and we chose where we wanted the data to be, for example. Yeah.
Okay. All right. Thank you so much.
Yeah, no worries.
Fantastic. Thank you so very much for those great responses. Thank you, Neji. Let's go to Victor. Victor Jumodu, are you there?
Yes, I'm here.
Okay, please. Yeah, go ahead with your question.
Okay, good evening, everyone. Or good morning, everyone. It's 2 a.m. here. So my question is, based on my engagement with the Bitcoin Center, I was engaged in a cohort-based program. And one of the projects they gave me, one of the projects I choose for myself to run was to do a voting application using the blockchain. So currently, like tomorrow in my faculty association, we're having an online e-voting. So I'm just asking, how possible would it be to integrate a kind of, or to create an e-voting application, especially for student election, using the blockchain? Are there steps or are there guidelines? Because I really need this support and help to also help me build on my own project for the blockchain voting application. Thank you.
Okay. Hi, Victor. It's nice for you to join us. I'm sure you are in Nigeria or in a different time zone and still joining us. We appreciate that.
In Nigeria, currently.
So what we can do is that through the Newbie Secretariat, we can send you a course. In fact, like I started my own blockchain journey, development journey, building voting systems for blockchain. So there are a bunch of courses we'll send you on Udemy. There's a course, in fact, that teaches you the whole Ethereum development using Solidity and all that, building a full voting system on that. So we'll the layers, eventually the association will send that across and you would have access to that. That way we can help.
Fantastic. That would be awesome. In fact, as we are discussing right now, I'm already envisioning having like an incubation session But it's something obviously we are going to talk about, Neji. Within the ecosystem, one of the things we've introduced is more like incubation programs. And the vision behind the incubation program is to, get our members to think beyond the traditional, tech-related, areas. One thing that we've seen over the years is that, most Nigerians come in here and you find out that majority, what they want to focus on straight away is project management, cybersecurity, business analysis. Of course, these are great domains, right? They are great areas, but we've got so many other areas, like artificial intelligence, machine learning, cloud computing, even the solidity you talked about. And look at the one you talked about again, Rust. I mean, this is my first time of hearing that, right? So we've got so many other areas for sure that, people have not even ventured much into. And I think really that is the future, right? Now we are talking about Industry 4.0 and the likes. We want to get members to begin to think along those paths because we think really that is where the future lies when it comes to tech. So I'll be having further conversation with you to see your schedules and how we are able to kind of put something together as well for those that will be interested to, because some of the chat I'm seeing right now, in fact, some already asking, how can I be like you? Those are the kind of questions I'm seeing on the chat. How can I, so people are already inspired, by what you do and by what you showed us tonight. So we really want to find opportunities and ways to tap into your wealth of knowledge. Thank you so very much. Let me move quickly to Kudrat. Kudrat. Yep.
Hello.
Yes.
Thank you so much. Yeah, thank you for the opportunity, Sita. And thank you so much, Neji. This has been a very, very wowing session for me as usual. The last one was very good, but this has taken it to another level. Thank you so much. So for me, I'm trying to bring home some of the things that you mentioned. I'm trying to, in my bid to understand some of the features and functionalities you've talked about today. So my first question would be, for the Smart Connect, is it like what you have in a certificate management solution, like you have in your Verify, where you have the SSL certificate exchange between two parties that are exchanging information with each other? That's the first one. And then the second one is the Hyperledger. I know that for enterprises, they have different modes of identity. They provide identity. They provide identity in different modes. You have the customer identity and access management, where you have services that you want to expose to your customers Oh, there's so much. Okay, you have services that you expose to your customers for identity management, all through APIs. You also have service to service identity management, where one technology API would exchange information with another API. And then you also have the employee or the enterprise identity management, where it could be an enterprise to an enterprise, or an employee connecting to a resource within the organization. So I'm wondering if all these identity management is going to be subsumed under the Hyperledger.
Okay.
That's number two. Then number three, I had a scenario, or I experienced a scenario in one of my projects where the hardware storage device that has multiple nodes, using some of those nodes are actually using NVMe drives, while some were using the SSD drives. So there was an issue where one of the NVMe drives went down, and the team were a bit confused why the outage of that NVMe drive led to a subsequent outage on all of the drives. So in my mind, I was wondering if there was some sort of a blockchain technology being used at the back to actually manage these drives. That's why that outage happened like that.
Okay.
So those are my scenarios. Thank you.
I just forgot question number 1 because I was solving question number 2. So please just remind me, what was question number 1 again?
The first one was about Smart Connect. I was wondering if, so I'm trying to bring it home, that is it the same as the certificate management provided by Verify and Co?
Yeah, no, basically we're talking smart contracts, not Smart Connect. It was smart
sorry, smart contract. I guess I missed it.
And you see, for certificate management, the way it works traditionally is the concepts are very similar within the underlying infrastructure of the blockchain. You're talking public keys, private keys. SSL is just an exchange of those. I have a public key here on this server. You have a private key here on the server. I present my public key. You validate it. That's basically what it is. So the foundational technology behind SSL is what's used to create the blockchain on its own. That's why we say that basically to create your own blockchain or your own coin or whatever is very deep. There's deep security. There's deep, all of that goes in at the back. So smart contracts basically, you can think of it as a layer or an automated guardsman, sort of, that automated guard that ensures that certain rules are completely abided by. That's basically what smart contracts are. So the underlying technology behind all of that is still the same thing, the same SSL, cryptography, public keys, private keys. You're correct in that. Now, for your second question, you're asking if the current models of the current enterprise connectivity models,
IAM models,
yes, are going to get up. So the answer is yes and no. And yes, because the current models most of these models are centralized. I'll give you an example, like SAML, the current model being used for, what do you call it? Active Directory.
Active Directory, yes.
The Active Directory must be stored on one tenant somewhere. It's one tenant, and that tenant has to be somewhere. So if somebody hacks that tenant, they've got access to the whole key. That's where I say yes. Then the no part is that there are subsystems now, there are hybrid systems that are coming up now that are utilizing the distributed ideology with the same, what do you call it? The same connectivity modules like OpenID. Almost all your login systems are built on what they call the, what's that same tech thing again? The OAuth.
OAuth 2, right?
Yeah, OAuth 2.0 model, OpenID, OpenConnect, all of that stuff. So one of the projects we're working on, the very same project we're working on, is combining blockchain, tying blockchain to the same OpenID, OpenConnect model and the same SAML, SSL, so that it can be used as a hybrid between two incarnations of technology where you have the old model and the new model. You understand? Okay. So yes and no. Yes, it may be subsumed or consumed, whatever. No, but because a lot of hybrid systems are coming up that will bridge the gap, because we cannot overnight just change from using passwords. We can't do that. Then the third question about the hardware, that in that case where one drive led to the smashing of the other one or the burning of the other one, if you had blockchain technology at the back, you would probably not have lost anything, because decentralization is the key behind blockchain. So keep spread the data or spread the info across board. That's the basic philosophy. So if one drive burning up, even if the second one crashed, as long as there's one node on the system, that's the thing we say in blockchain, as long as one node is alive somewhere, the data will never be lost. So I hope that answers your question, more or less.
Thank you.
Yeah. All right. Thank you so very much, Neji. Thank you. We've got a question from Okechukwu, and you just want to find out what could be the career path for a newbie in tech. A newbie in tech that want to delve into blockchain, just like you are. What do you envisage to be the career path?
Okay, to answer that question, I would say, when you say newbie in tech, newbie is relative, because it could be that you are, first things first, you've got to learn our advice. You need to learn one programming language. If you want to get into space, you've got to learn likely I would always suggest that you either start, I don't like people starting with Python, because Python is easy. If you get you swallow Python, you would completely go that way and you whatever. So I'll always go and start with Java or JavaScript so that when you meet Python, when you meet the easy one, it will be easy for you. So first things first, you've got to get an appreciation of programming languages, maybe JavaScript first of all, because to even do blockchain, you need some amount of JavaScript. So I'll say to start with JavaScript, learn how to build web pages first of all, learn how to build websites, how to code websites on web apps on your own. Then you would go into databases, try and understand databases. Then if you can do those two, then you might, I think you have a good chance by saying if you jump into Ethereum development using Solidity, because that's one area where we are seeing DeFi apps are going to be like exploding. They're all built on Ethereum, more or less. So I would suggest that you start, and don't worry, give yourself time, give yourself 9 to 18 months. You would, in no time, you will find yourself on that path. And of course, Nipka is here to guide you. So we'll always be available to at this point you in the right direction.
Fantastic. Thank you so very much, Neji. So we've got 2 more questions to go. That is that from Damilola and Anthony. But before that, please, guys, I want us to, all turn on our videos if it's possible. Let's turn on our videos so that we can take a quick peek with Neji. Okay. Thank you, Musbadin. Dami, thanks. Yeah, let's turn on our videos, guys. Wow, Emmanuel, are you in the crowd? I love that. Kudrat, can we see your face? Tega, Victor.
Coming. I'm putting on my makeup.
Makeup.
Don't mind me.
Victor, can we see your face?
Huh?
Tega, okay, great. Ola, Infinix S4. All right, great. I think this is good enough. Remy, please. Papalazzi.
Are they show for camera?
Yeah. Remy, are we good? Remy, are we good?
Yes, I can go.
Say cheese.
We should say cheese again. Are we good? Remy, you're muted. I can't even hear you.
One more, please.
Okay. No, allow this my smile to go away before you. Okay, Shay, yeah.
You allow it to expire.
May the spire not expire, I beg. We thought,
thank you.
yeah, fantastic. All right, thanks, guys. Quite appreciate. And if you don't mind, just keep it that way until we wrap up, if you don't mind. Look at how some beautiful faces now. Why are we just hiding the faces like this? Let's wrap up this way. I think that would be great. Then, Danny, you've got a question, right?
Yes, I do. Thank you so much, Mr. Neji.
The man with the golden voice. Go ahead, please.
Yeah, so my question is directed at what you just said. So I'm one of those who didn't watch Prison Break since it came out since 2005 until this year. So I'm 16 years behind. But then I saw something interesting. Someone just called and said they were trying to get someone's voice to kind of loop over and create more words. And then someone called and said hello. Just with hello, they were able to create sentences out of the person's voice and deceive another person, get some other things. So it was new to me. So apparently I'm very far behind in this technology thing. Okay. So my question is, I do voiceovers. I've got friends who do voiceovers. A friend of mine calls me from Nigeria and says she was already bidden to be like the voice for something, and they were going to pay her about 200K. Now, 200K is small for many people here, but in Nigeria, it's not too small. To read one script of like 5 paragraphs and you get paid 200K is not too bad. But before she knew what was happening, someone else had already used her voice, a sample of her voice, and created the same thing. At that event, they read a biography of the rich man who died, and it was her voice. She didn't go there. She didn't participate. That was terrible. So they took her money away from her, but they used her voice. We can't say because it's Nigeria, these things are fantastic. It's okay. You can go that way. You can't fight it. I'm thinking into the future. You talked about this non-fungible tokens, all right? where whatever you put out as your original content is yours. But what if you've not put it out yet? You've not written the words yet. You've not spoken the words yet, but it's your personal identity, your biometric identity, or your biographical identity, your personal life. More like, we know about intellectual property, right? But what do you call your fingerprint, my voice texture? How can someone pick my voice texture and go and read an entire audiobook and get paid royalties from Robert Kiyosaki's billion-dollar selling book? How can I protect myself against something like that? Okay. What do I need to do? How can we voiceover artists create platforms along those lines so nobody's going to just steal my identity, so to say? Mine is just very straightforward like that.
Well, it is a very, in fact, that's what's happening in that sector is actually super scary. And in machine learning today, there are neural networks that actually have been built and trained that only need to listen to your voice or you speak for 30 seconds and completely speak like you. In fact, there is one. I'm looking at one right now, and in fact, it's called voice cloning. It's a new area and it's very, very dangerous. So and I suspect that these guys who are calling you, sometimes these fake numbers we keep seeing on our phone, the dialogues, you pick up, you say hello, you don't hear anybody, and then after this thing called spam. I suspect those folks are recording our voices and trying to synthesize our voices to be used on to try to trick the bank systems, because most banks use what they call secure voice. So over the phone, they use this sort of AI to sort of like try to tell the probability that you are the same person on the phone when you're talking. So, and for your friend, they use the particular voice replication tool. I'm not going to mention it, but it's one particular one that was probably what was used. Now, to secure your voice or to protect yourself from such, NFTs present an opportunity, like you just pointed out. So, for example, if you have, but the thing is, you have to do a full recording of something and then you put it out there and say, oh, this is originally me. That's one way we can think around it. And the other approach is that there's also counter AI solutions too that are built to detect this auto-generated voices. So it's an area I'm actually interested in researching. So I think more research is needed there. We should talk about this more maybe behind the scenes later, so we can look into that. But NFTs are going to be a good way to do that, to protect your voice. And voice authentication is also another powerful area, and where we're trying to ensure that people cannot trick machine learning systems too, like that. Yeah, so new area, but certainly not lots of prospects in that regard.
We have classifiers in this area.
Sorry?
Do we have classifiers?
Well, in that space, we're not doing regular classification. We're doing deep neural networks. So there are neural nets that are very, very powerful. I think there's one called VoiceNet or something like that. So all it needs to do is just learn. It learns basically what is voice. Voice is just electronic voice supplies an electrical signal that is modulated. So you are, if you get a network that can grasp even the finest print of your voice, it can replicate that. I'm sure you've heard of deepfakes. There are deepfakes might be a deepfake algorithm that was being used in that case. So there are also tool sets that are being developed have been developed and good at detecting deepfakes. So we can also look into that and see how that can work. But it's a pity your friend, she got those folks. That means those guys have gone, they've gone sophisticated in Nigeria. That's what it means. Yeah.
Thank you. My apologies to the moderator. Sorry, I didn't introduce myself. I'm listening to you from Cranfield University in UK. Thank you. I'm a Nigerian.
Oh, nice. That is Samuel, right?
Yes.
Wow. All the way from Cranfield in UK?
Yeah.
Nice. Do you have any questions for Neji?
Actually, I lost out about the time. I set my Zoom at that 12 o'clock, but when I dozed off, and when I came out, he has done most of the presentation, but because I was interested in some of the things, the summary he was giving, I decided to sit back and listen. And while the other people were asking questions, I was also benefiting from his explanation. Maybe I will find time and see how best I can interact more with you, and then I will have more questions for him, especially this key area that he has mentioned about neural network, because the neural network goes first in, pari passu with the classifiers I'm trying to mention. And using the intelligent neural network, I'm trying to see how, if we can use that to be able to classify the identity of the people and match it with the voice. I think it will go a long way in helping some of the issues that the other person has just asked a question about. So apart from getting the voice set up, you also classify it with the imagery of the individual involved, just like we match our biodata with the other aspect here he demonstrated during the Paytalk. Thank you.
Yeah. Yeah, so that is in fact, there's a field called voice biometrics. It's something that is still emerging, but it's not perfect yet. So what Dami was asking is there a way to protect players in that sector like himself who are voiceover artists? So one of the things you can do is that you can actually, one thing is you have to protect your brand using traditional methods. You've got to be out there, let people know that this is the real you and all that. And you can put your works on the blockchain. So they just know that if you are for example, your bookings, it can be simple like this. All your bookings go on a certain blockchain. So you verify that this is actually, I am the real person who's participating in this event on this date. You understand? So if you have your information on there, that all your bookings, all your events, people know that this is not the real you, and it will invalidate whoever it is that's trying to clone you or clone your voice. You know.
Sorry, but just one more question about events. That's quite straightforward. It becomes more difficult when we're talking about a case where an author of a particular book, a 200-page book, doesn't really care. The hard paperback cover of that book may be selling 1,000 copies per year, but when it's converted to audio, in an ordinary voice, it will sell the same 1,000 copies per year, but in what you classify in radio as preferred voice texture, it will sell 1 million copies. They don't care if I sign it or not. They don't care if they check my thumbprint or my biometrics against it. The book is selling. He doesn't care. He's the author. He just wants to sell. That's where the protection comes through. So it's not about just events alone. I'm talking about we need to create platforms, like real platforms, where until I sign off with my fingerprint, anyone who tries to use that particular voice texture will not be able to go through those kinds of things.
Yes. Yeah, and that's the world of NFTs. That's what you do. So you can mint your voice into an NFT, and possibly you put a stamp of authenticity on it. So, and these are areas where we need more. Like we say, we need more people to think around these problems. You know, we need more engineers to come up and say, "Oh, okay, there's a way to do this," and somebody will find a solution along the way. So it's an opportunity. It's a problem, but it presents a huge opportunity for anyone willing to go down that line and research it.
Yeah.
Yes, well, thank you very much.
Yeah, thank you very much, Neji. Totally agree with you. We need more men in this space for sure. No doubt about it. More men. Prof. Jexy, we need more men into this space. All right, so
we are there.
Yes, let's get to Anthony. Anthony, are you still here? Anthony. I think Anthony DK, right? You were raising up your hand. Okay, so let's get to Emmanuel. That's the last question for the day. Emmanuel, please make it brief.
I get the last question. Great presentation, Neji. Wonderful material that you have there. I just have a question around, is there any planned framework around the blockchain or any governance? I'm asking this in the background of the regulation passed by the Central Bank of Nigeria. You can understand that there's fear of uncertainty, it's not regulated. Is there anything planned, or is the joy of blockchain is the liberty?
Okay. To answer your question, currently we have to go back to the philosophy behind this whole blockchain movement, and we start with why Satoshi built the Bitcoin blockchain, and which became other things. So originally, the blockchain was meant to be this whole platform where you have freedom. We didn't want any of these government regulations and all that. That was the original concept behind it. It was this group of folks libertarians who don't want no government thing involvement. They wanted a straight approach. So, but over time, the use cases have evolved, and we've seen. And so, a lot of countries, what they've done is that they've seen that blockchain is a double-edged sword. Terrorists can use it to finance themselves. Kidnappers can use it to change. At the same time, it can enhance flow of transactions. It can be a very powerful source of wealth creation. So it's like a double-edged sword. So the way a lot of countries, sensible countries, are mitigating is that they are using KYC at the onset. So as an exchange, usually to sell your coin or to transfer, usually you will use an exchange. You understand? So a lot of exchanges require you to have to KYC first. So you need your phone number, you need your ID and all that. So what sensible governments are doing is that they're actually going after those exchanges, putting laws in place to ensure that for you to run an exchange, you must provide a certain level of KYC. I'll give you an example. FinTrack in Canada, even all the crypto businesses in Canada are subject to FinTrack regulations. FinTrack is the body that handles like a CBN that coordinates that sector. So that way, even if you're buying crypto or Bitcoin, they can track you. And then there are other technologies too in place that are being worked on to sort of like help identify wallet ID. So if you have a wallet that has your crypto, it's tied to you and stuff like that. Yeah. So the countries that fear it, the countries that outrightly ban it, countries that are not really, if you look at it, they're not really forward thinking. The real forward thinking countries are thinking of how to regulate it. That's my own personal opinion, though.
So you say that the CBN policy was not well informed.
Well, I don't know. I don't know. I'm not in CBN, so I can't speak for them, but I can speak for the Canadian system here and say that they are looking at ways to actually ensure that it is not abused. You understand? Yeah.
Thank you.
So in a nutshell, it should be regulated, right, instead of outright banning. I think that's what Neji is saying, and I think most of us share that position as well. I believe probably the CBN, they have got their data, they have got their reasons, but trust me, with the way things are going, maybe you'll be very surprised in the next couple of days. There's going to be a communique again from CBNs, because there have been so many policy somersault, right? If you look at the administration, it's been difficult to really stick to a particular policy, But again, this has been a wonderful and great session tonight. I believe that most of us have learned a thing or two. I personally, I have. Thank you so very much, Neji. We really appreciate you so much for, one thing about you is that sharing with us, it's not like just talking. When you share with us, we see the passion. That kind of thing, right? Because the passion is infectious. And that is why someone like Kudrat is already warming up now to, start programming in Solidity. So that passion is infectious. And that is the kind of thing we need, because in a way it inspires people to believe that, yeah, this is possible. Thank you so very much. We really appreciate you. Guys, can you unmute yourself and let's give Neji a round of applause. He truly deserves it. A round of applause to him, please. Yeah.
Thank you so much. Thank you.
Yeah.
Thank you, Neji.
Yeah.
Thank you,
fantastic.